All right. So we left off yesterday. We were talking about these piecewise functions, right? And we left off here. We were just introduced to a piecewise function. We'll see if we can get through just this example and maybe one more today. So click them all closed, put everything away. Everybody kind of get your attention up here so we can understand what's going on, right? So the whole point of this piecewise function is so that we can represent different behaviors for different domains, for different values of x. This piecewise function here, hey, Abby, why don't you, I know you probably think you got stuff going there, but watch this now and then you won't have to try to recreate it later. In this case, f of x is defined as the red graph whenever x is less than or equal to -2. And so that's the part we took care of yesterday, right? We set up these vertical boundary lines, which really aren't part of the graph. They're just there for our convenience, but they partition the XY plane into the regions corresponding to the pieces on the piecewise function, right? So the red region, color coding it, the red region is going to be the place where all the x values are less than or equal to -2. So give me 1 to 5. Does that make sense that that's the red region then? Everybody get that? That's the part of the xy plane where the x coordinates are all going to be less than or equal to -2, right? So in that region, we graphed the red behavior, right? The red function. And that turned out to be, that's just y equals 2x, which is a line, right? And to graph that line, we just need 2 points. Well, we want to pick one point that's right on the boundary line, so we know where the thing stops when it hits the boundary line. And then just some other convenient point. And all we're going to do is make a little t-table so we can get 2 points on that t-table. If we plug -2 into our function, we got the ordered pair -2, -4. If we plug -4 into our function, we got the ordered pair x is -4, y is -8. And so we created those 2 points. And because -2 is included in the red domain, we used a closed endpoint on the boundary. Okay? Buddy, give me thumbs up, down, sideways on that. How are we doing on that first part? Okay, I mean, a little bit of this, okay, so this is still a little iffy. Let's keep going and see if we can tackle the rest of this then. So the next part would be the blue piece. Okay, the blue piece is what we graph between the x values -2 and 4. So it's going to be in this region in here, right? That region. That's the blue region. Give me thumbs on the blue region. Does that make sense? That's the blue region. That's the region where x is greater than -2 and less than 4. And it doesn't, by the way, it doesn't stop here, right? It goes up forever and down forever. I'm just graphing the part that we can kind of see on our graph. Okay? Give me some feedback on this. Everybody get that? Or yes or no? I'll be honest because I want to make sure this is important to understand before we move on. Okay, ask some questions. If you can think of a question, boy, that really helps. Helps you and everybody else. So if an ant were walking along this function, where would the ant be if the ant's x value was -10, right? If the ant's x value were -10, wouldn't we be up here on this red region? Everybody get that? You see how that works? Because look at these x values, right? These are the different places where these pieces are defined. We have to look at these and see which one of the three does -10 fit into, because it can only fit into one at a time, right? Only a certain x value is only ever going to fit into the red, blue, or green regions. Well, -10 is less than or equal to -2. It's not greater than -2 and less than 4, and it's not greater than or equal to 4, right? So if an ant were walking along the graph of f of x, he would be on the red part of the graph when x equals -10, right? And the red part of the graph, again, is just the line y equals 2x. Okay, well, where would he be then? If I plug -10 in, the y value would be at -20. right? He'd be way down there somewhere, right? So he continues walking along the red graph until he gets to a value x equals -2. And that's where it shifts from the red piece to the blue piece, right? So as soon as the ant takes that last little itty bitty ant step and passes through the number x equals -2 to something a little bigger than that, now he finds himself walking on this blue line, right? And the blue line, the equation of the blue line is just that. Y equals -1 minus x. Okay? So we need to know what is the shape, what's that line? Where's the ant going to be walking? So we got to graph the line for those x values where x is greater than -2, so to the right of this boundary line, and less than 4, so to the left of that boundary line. Okay? Does that help? A little bit? Okay. So to get that line, we just need 2 points in that region. I could pick any x values I want to between -2 and 4, right? But the most convenient ones to use would probably be what? Say it again. I could do -1. It'd be fine to do. I'd say -2 and 4 because those are the endpoints, and that way I know exactly where the line starts and where it ends. Just makes it a little bit easier to graph. Does that make sense? Okay, so what if I plug in x equals -2? Well, just plug that into my function. -1 minus -2. Subtracting -2 is like adding 2, right? So -1 plus 2 is just 1, right? So I get the ordered pair -2, 1. Okay, that's where the ant picks up on the blue part, leaves the red part and jumps onto the blue part. Okay, now is the value -2 actually included in the blue domain? Look up here at the blue domain. Remember, domain are the input values of the function, the x values, right, that we're going to plug into the function. These are the only x values we can plug into the blue function. Is -2 included? Give me thumbs up or down. How come? You're right. You guys are right. Ben, how come? Okay, yeah, the correct answer is no. It would have been thumbs down because look, this inequality right there doesn't include an equal sign, right? So -2 itself is not included in the blue region, and we already knew that actually because it was included in the red region, right? So what kind of an endpoint would I have to put at this point then at -2, 1? That's the left endpoint of the blue line segment that we're graphing. Got to be open, doesn't it? Right? Everybody get that? Because we're not including the x value -2. So let me grab an open one. And we're going to put that over here at x equals -2, y equals +1, right there. Okay. And then how about picking x equals 4 so we know where this line segment ends up when it hits the other boundary? Well, if I plug 4 in, what's -1 minus 4? -5. Everybody see where we're getting this, right? I'm just plugging these values in for x into my function to calculate the y value, okay? So we get the other ordered pair, 4, or -5. Again, is 4, give me thumbs on this, is x equals 4 included in the blue domain, so in the blue region? Everybody vote. Look at the inequalities up here. Is 4 included in the blue? Does the inequality contain an equal sign? Oh, so it's not then, right? The only x values included in the blue domain are the x values greater than -2 and less than 4. Not 4 though, right? So again, we're going to need another open endpoint there, aren't we? So let's grab another one. And we're going to go to the point x equals 4, y equals -5. So right there. Those are the endpoints. Then all I have to do now is just connect those with a line segment, right? Because this is a line. So lines are defined by 2 points. So I'm just going to do that. Okay. Give me thumbs. How we doing? Okay. All right. So there's the blue part. Now let's scoot forward again. So there we go. Now we're going to get the green part. Well, the green part, the green region, again, it's not just, doesn't stop here. It's infinite, right? It goes infinitely far to the right of this boundary line. Right? Here's the boundary line. It's everything to the right of that boundary line. It goes up forever, down forever. It wasn't convenient for me to try to do that on the board, right? So I just gave you a little snippet of it, right? Okay, well, to the right of 4, we get the line y equals -3. What does that look like? We've had tons of practice. At this point, we got to know what that is, right? If y equals a number, show me with your arms. What's that look like? Y equals a number. Yeah, that's going to be horizontal, isn't it, right? We know it's horizontal. That line would cross the y-axis at -3, only it doesn't go that far because we're only drawing it in the red region, right? But we know it's going to be a horizontal line with y coordinates -3. If I wanted to, I could easily go up here and just plug in some values, right? But it doesn't matter what values I plug into the function because the y coordinate is always -3, right? So I could do 4, -3. Give me thumbs again. And if you're not sure, please ask a question. Is x equals 4 included in the green domain, the green region, or not? What do you think? Mayland, how come? You're right. How come?
I'm not sure. I didn't feel like it is.
Okay, so it was y is x. Now, it was included. We had a closed endpoint in the red region at -2 because the x values that go into the red region include -2 because of that equal sign on the inequality. We had open endpoints at both of the blue endpoints because the x values included in the blue region, the blue domain, we could say, don't include -2 and 4. They're just the values between those because the inequalities don't have equal signs, right? Okay, so now, what do you think? Why do we have a solid endpoint on the green part of the graph? Because of the equal to, exactly, because x is greater than or equal to 4. So because of that equal to, it is a part of the green region and we need a closed endpoint. Good. Okay, so let's grab a closed one down here. Okay, and so we got one over here at -3. And then if we could pick any other point we want to, like, in Math Excel for school, you'd have to pick 2 points to define the line. So maybe we'll just pick one over there at x equals 8, y equals -3. And this is what we end up with then. Okay? Good? Okay. All right, so now we got the graph. Now we need to write down the domain and the range. So the domain is all of the x values included in the whole piecewise function, all the pieces combined, right? So a good way to think about this would just be, let's project the entire piecewise function, squeeze it onto the x-axis and see what we get. Okay. Well, what about the red piece of the piecewise function? What's the domain of the red piece? Where do the red x values start and where do they stop? What do you think? Like if I took that entire infinite red piece of the piecewise function, which is actually a ray, isn't it? If we go back to geometry, it's got an endpoint, but it's going to go forever down and to the left, right? So if I wanted to collect all the x values, I wanted to squeeze all those infinite points onto the x-axis to see what the domain is, what would that look like? What's it going to be? Okay, so it's going to be, where does it start? At -2. Okay, good, because this point right here, oops, wrong color. This point right here is going to get squeezed up to there, right? Everybody agree? So that's the biggest red x value is -2. If I pick these other points, they're just going to get squeezed up onto the parts of the x-axis to the left of -2. So what would that look like? Well, it just looks like that, doesn't it? Everybody get that? Those are the red x values. What are the blue x values? -2 to 4, not including those values though, right? I'd have to have an open endpoint there, but it's already filled in by the red. Over to here, and I've got another open endpoint. There's the blue domain, right? How about the green? What would the green do, Miranda? The green x values start where? The x values. Okay, so they start up here at 4, and then they're just going to go to the right forever, aren't they? So it fills in that open endpoint and just keeps going to the right. Well, what did we get? Everything, didn't we? We got all reals. There were no gaps in that. Every x value, the ant always has a place to stand, right? There's no x values where he doesn't have a place to stand on this thing, right? So the domain then is all reals. Okay? All right. Give me 1 to 5 on that. Okay. All right. It's tricky stuff, isn't it? We're sort of getting there, though, I think. How about the range? Same game with the range. We want to take each of these and figure out what are the y values included in each of these pieces and then combine them all together. Okay. So what about the y values included in the red piece? Describe those. How would that look? Mackenzie, what's the range of the red piece if I were to project those onto the y-axis, because the range is the set of y values? What would I get? Okay, so -4 would be that one, wouldn't it? We know that, and then where does it go from there, up or down? Down forever, doesn't it, right? So there's the red range right there. Okay, this guy would just go over there, for example, right? Okay, what about the blue range? Johnny, what do you think? Okay, so up here at +1, we're going to get an open endpoint, right? And then it's going to go down how far? To -5. Okay, so clear down to here. That's going to be open. But look, that one's already filled in, isn't it? Right? That overlaps with the red range. The red range already included that point. Okay. And then from that point, it would just go up to there. So far, that's what we've got, right? And then what about the green range? What does the green range include? What are all the green y values? Only one of them. It's -3, which just gives us 1 point there. But we already had that point. That was already part of our range. So combine all those. Doesn't that just give us everything from -infinity up to, but not including +1? Does that make sense? So the range of this piecewise function extends from -infinity at the bottom up to +1 with a parenthesis, though, because it's an open endpoint. Okay? Give me 1 to 5 on that. How we doing? Okay? Getting there? Okay. All right. We're getting there. Okay, good. Good. Let's just try maybe one more of these. Okay, we're going to just do this one all at once here. So we've got this piecewise function. Let's color code this thing again, right? So we're going to make this top one, we'll just make that the red piece. Middle piece we'll just stay the same way we did last. Whoops, that's going to be blue. And bottom one we'll make green. Okay, so I need to partition this off. Where is going to be the red region? Where do I need to make a vertical boundary line? At where? At 0, right? Everybody see that? So at x equals 0, we need to put a vertical boundary line. So there it is. There's x equals 0. And the red region is going to be to the left of that when x is less than 0, right? So to the left of that boundary line, we're graphing y equals negative 3x. Where's our other boundary line? Everybody agree at 6? 6 is the other place where we're going to jump between pieces. Okay, so over here at 6, 1, 2, 3, 4, 5, 6, we've got another boundary line. In the middle is going to be the blue piece. So that's going to be, we'll just look at what is that function. Well, there it is. It tells us right there. Y equals negative 1/2 x minus 1. And then to the right of 6, we're down to the green piece of the piecewise function, which is the line y equals x minus 7. Okay? Give me 1 to 5. Everybody okay with that or no? How are we doing? Okay? So now in the red region, we've got to graph that red function. Okay? So we need to pick 2 points. What's one point we definitely want to include? 0, right? Because we want to know where does it end when it gets to the right of its domain. So we're going to make a red t-table. And we're going to plug in 0 for x. Well, what y value do I get if I plug in 0 for x? Y equals negative 3 times x. So if we're letting x equal 0, what do we get? Yeah, negative 3 times 0, which is 0. Okay? So there's our right endpoint of the red piece, right? Open or closed? Look at the domain up here. Is it open or closed endpoint for the red piece? How come? Randa, how come? That's right, it's open. How come? For the red piece. Okay, they're not equal to, you mean, right? There's no equal to, good. So that's going to be an open endpoint. And so I guess I have to make my own here. That's all right. So we got an open endpoint at 0, 0. We need another one. How about if we just pick like negative 2? That good? I just want to pick one that's going to kind of stay on the graph. So if I pick x equals negative 2, y would be negative 3 times negative 2. What's that? 6. Heard it? Okay. So positive 6. So we've got a point at x is negative 2, y is 1, 2, 3, 4, 5, 6. So right there, I guess my t-table's a little bit in the way, but we get the idea. There it goes. There's my line. Just keeps going, right? Okay. Open endpoint on the right. How about the blue? What are the values I'd want to plug into the blue t-table? 0 would be good, right? Because that's going to be the left edge or the left endpoint of the blue piece. So let's try that. So I'm making my t-table. X equals 0. Okay, Abby, if I plug 0 into the blue function, I'm going to get negative 1/2 times 0. What's that? 0, good. Minus 1 leaves me with negative 1. Okay, so I get the endpoint 0, negative 1. Abby, is that going to be open or closed at 0 for the blue? Closed, good, because we're including the equals there. Good. So we get the point x equals 0, y equals negative 1. So there's my closed endpoint on the left. And then we already said we want to plug the other boundary in, so 6. What's that going to give me if I plug that boundary in, Ben? If I plug 6 into my function for x? Yeah, good. I'm going to get 1/2 times 6 is -3 minus 1 is -4. So I get a point at 6, -4, open or closed? Ben, what do you think? Open or closed? Open, good. Because at 6, the blue domain doesn't have an equal sign, right? So it's not including that. So 6, -4. I'm going to go clear over to here, down 4. I got an open endpoint. I'm going to connect those two because it's a line, right? And then finally, what about up here at the green piece of this? Well, we want to, what's one value we definitely plug into the green portion? 6, because that's the endpoint. Okay, so what's that give me? If I plug 6 in for x, what do I get for y if I plug 6 in? -1, yeah. 6 minus 7 is -1. Everybody open or closed? Look at the piecewise function. Open. Yeah, because look, the green domain does not include 6. It's just the edge of it, right? But it doesn't include 6. So we've got 6, -1, got an open endpoint, and then we need one more. How about if we plug in 8? If I plug 8 in for x, what do I get? 8 minus 7, 1. Okay, so 8, 1. So I'm right there, over 8, up 1, and I just connect and extend to the right. And there's my piecewise function. What a beauty, right? There it is. Okay, let's see if we can figure out what the domain is. Okay, the domain. If we look at the red domain, describe the red domain. Miranda, what's that look like? If I compress the entire infinite red piece onto the x-axis, what would I get? Okay, because you're looking at that one right there, right? Okay, but remember, my stupid t table got in the way, but this thing actually just goes forever. Okay. And where's it stop? 0. Okay, open or closed? Okay, good. So we get the red domain looks like that. Agreed? Okay, the blue domain. Maylin, what's that do? Where's it start? 0. And it fills it in, doesn't it? Because it's solid. Okay, so this guy goes up there and fills that in, and then it goes over to where? 6. Okay, and it's open at 6, isn't it? Okay, while you're at it, how about the green one? It stays open. Yep, stays open, and then it just goes to the right forever. Okay. Okay, so there's our domain. Now, is that all reals? What value are we missing? Yeah, we're missing 6. So the domain is x is not equal to 6, which means everything else is okay. If I wanted to write that with interval notation, it's kind of inconvenient. How would I write that using interval notation? What would I do? Interval, remember, that's where I got to use parentheses, infinities. How would I say how do I write in interval notation everything but not 6? Where would it start? Okay, so it starts at -infinity and then it goes all the way up to, well, it'll go all the way up to 6, but what kind of do I need parenthesis or bracket? Parenthesis, because remember 6 is not included. Okay, so I'd go all the way up to 6 with a parenthesis, and then I've got to have or, right? Because I'm going to have two separate regions. So remember the U is how I'd say or with interval notation. And then what's the other part? Where does it pick up again? Okay, yeah, it's going to be parenthesis and a 6, right? All the values greater than 6. So 6 to infinity. So the only thing we missed there was that 1.6, that one single 0.6, right? Okay, are we out of here like in 1 minute? Okay, that's probably a good place to stop then. All right, good job.